Okay, in this video, this is exercise 13F. We are going to look at question number 3. Let's have a look at the question. It says an isosceles triangle ABC is formed by 3 lines. Line AB in the vector form, then you have line BC and you have line AC. So there are 3 lines given to us. These 3 lines make a triangle ABC. Your question is, use vector method to find the coordinates A, B and C. Okay, so we need to find out the points of intersection of these 3 lines, and they will give you the 3 vertices. So first I'm going to look at vertex A. To find vertex A, we need to consider the 2 lines AB and AC. So look at the line AB and AC. So the point of intersection will be point A. A is the point of intersection of the 2 lines AB and AC. So we're going to consider these 2 lines AB and AC. So I'm going to pick them up, but I want these lines to be written in the parametric form. So I'm going to write my AB in the parametric form. So AB, if you look at AB, equating the I coefficients, I get x is equal to 0 plus 2r, y is equal to 2 plus r. So I have my L1 written in the Cartesian form, and from AC, from the second line L2 AC, from AC if you see, the corresponding parametric form will be x is equal to 0 plus 1t, which is x is equal to t, and y is equal to 5 plus t into minus 1 is minus t. So I get 5 minus t, y is equal to 5 minus t. So I wrote the first line AB in the parametric form, second line AC also in the parametric form. Now, if they intersect, if the 2 lines intersect, then there will be a common point between the 2 lines. They will have the point where they intersect will be common to both the lines. So they will share the same x coordinate and the y coordinate at the point of intersection. So if they intersect, if these 2 lines intersect, then the x coordinate from AB has to be equal to the x coordinate from AC for a specific value of t. So I'm going to say t and r. So I'm going to say 0 plus 2r, which is 2r, is equal to t. I equate the x coordinates. I also equate the y coordinates now. So 2 plus r has to be equal to 5 minus t. The y coordinate from AB is 2 plus r. The y coordinate from AC is 5 minus t. So 2 plus r is equal to 5 minus t. So one more time quickly, what we are saying is, we wrote both the lines in the Cartesian form, and we say if they intersect, they should have the same x coordinates and same y coordinates at the point of intersection. That is, for some value of t and r, the x values must be the same. So x value from here 2r has to be equal to t, and the y value from here, which is 2 plus r, has to be equal to 5 minus t. What I'm going to do is, in equation number 1, I know that t is equal to 2r. So I'm going to replace this t by 2r into this equation, the second equation of mine. So 2 plus r is equal to 5 minus t, t is 2r. Then I try to solve for r, bring all the r's together. So r plus 2r is 3r, and 2 goes to the other side. So 5 minus 2 is 3. So 3r is equal to 3, therefore r is equal to 1. I'll take this value of r, put it back into equation number 1, so that I'll get t as well. So when r is equal to 1, so I got t is equal to 2. And then now what I'm going to say is, when r is equal to 1, my value is r is equal to 1 here and t is equal to 2. Don't forget that. When r is equal to 1, I can go back to AB and calculate that specific point which is being shared by the 2 lines. So I'll say, when r is equal to 1, what is my x coordinate? X coordinate is 2 and y coordinate is 2 plus 1, which is 3. So x coordinate is 2, y coordinate. So when r is 1, the point corresponding to this specific value of r on AB will be 2, 3. Now I have the value t is equal to 2. This value of t is equal to 2, I'll put back into AC, the second line, t is equal to 2. So I'm going to say when t is equal to 2, what's the corresponding point from AC? I go to AC, AC says x is equal to t, but t is 2, so x is equal to 2, and y is equal to 5 minus t, that is 5 minus 2, which is 3. So x is 2 and y is 3. Therefore, the value, the point on AC corresponding to t is equal to 2 is 2, 3. So now I can see that there is a point 2, 3 on AB. There is a point 2, 3 on AC as well, which means 2, 3 is a common point on both the lines AB and AC. So the point A has to be 2, 3, the point where they intersect. That's how it became a common point for both AB and AC. So we conclude that they intersect and the point of intersection is 2, 3. So A is 2, 3. So we found the point of intersection of the two sides AB and AC as A, which is 2, 3. If I need to find out B, I should look at line AB and line BC. So I should look at AB and BC to find out the point B next. So I copy AB and BC and I said I'm trying to find out the point of intersection between these two, which is B. I'm going to write AB in the parametric form. So x is equal to, look at the equation and write the parametric form. X is equal to 2r because 0 plus 2r, and y is equal to 2 plus 1r. So that's AB's parametric equation, and BC is x is equal to 8 plus s into minus 1, which is minus s, and y coordinates, when I equate, I get 6 minus 2s. So we have the parametric equations written for both AB and AC. Now we say if the two lines intersect, if they intersect, the x coordinates must be the same. So 2r has to be equal to 8 minus s. So I equate 2r with 8 minus s, rearrange it like 2r plus s is equal to 8. That's equation number 1. And now when I equate the y coordinates, I get 2 plus r is equal to 6 minus 2s. 2 plus r is equal to 6 minus 2s. Rearrange it with both the variables on one side. So r plus 2s is equal to 6 minus 2, which is for equation number 2. So I have two equations here, linear equations I'm trying to solve. Try to make one of the coefficients the same. So what I'm going to do is I'll do 1 into 2 and 2 into 1, 1 into 2 and 2 into 1, so that my s terms will become the same. Equation number 1 multiplied by 2, 1 into 2, equation number 1 into 2. So 4r plus 2s is equal to 16. And second equation, you keep it as it is, into 1. R plus 2s is equal to 4. Then I subtract the two equations, and when I subtract it, 4r minus r is 3r. 2s and 2s will get cancelled, is equal to 12. So r is equal to 4. So got the value of r as 4. Put that back into one of the equations to find s. Into equation number 1, 2 into 4 plus s is equal to 8. So s is equal to 8 minus 8, which is 0. So got the value of s as well. So we have the value of r and s. So I will say when r is equal to 4, when r is equal to 4, a point on AB is, I replace r by 4 in AB's parametric equation. So r is 4, so x is equal to 2 into 4, which is 8, and y is equal to 2 plus 4, which is 6. So the corresponding point on AB is 8, 6. Next is s is equal to 0, and when s is equal to 0, I get a point from BC. So I go to BC and make s as 0. So a point on BC will be x is equal to 8 minus 0, which is 8, and 6 minus 2 into 0, which is 6. So the corresponding point on BC would be 8, 6. So both AB and BC have this common point 8, 6 on them. So that has to be B. Therefore, they intersect. The two lines intersect at 8, 6, and therefore B has to be that point. So we found the point B as well. Now we have the line, the other two lines left to find C. So that's going to be, we say to find C, we consider the two lines BC and AC. So you go to look at the line BC and then AC, these two lines. First thing is you convert BC into parametric form, also AC into parametric form. So we're going to say BC is in the parametric form 8 minus S and y is equal to 6 minus 2s. So got BC done. Now AC, look at AC. X is equal to 0 plus t and y is equal to 5 minus t. So got both the lines written in the parametric form. Now what do we say? If these two lines intersect, then they should share the same x values and same y values. The x coordinates must be same. So 8 minus s is equal to t, equation number 1. The x coordinates are same, 8 minus s is equal to t. And the y coordinates must be the same. 6 minus 2s is equal to 5 minus t. I know the value of t from equation number 1, which is 8 minus s. So what I am planning to do is, into the second equation, I'll take out t and put 8 minus s in there. So that will become 5 minus, in brackets, 8 minus s. So that's what I would do there. So 5 minus 8 minus s. Then I open the bracket with the minus sign. So that will become 5 minus 8 plus s. So I try to rearrange it and solve for s. So I take minus 2s to the other side and make it 3s. Bring minus 3 to the left side and make it 6 plus 3, which is 9. So I get 9 is equal to 3s, so s is equal to 3. Got the value of s. If you put this value of s back in equation number 1, I'll get also the value of t. So equation number 1 becomes t is equal to 8 minus 3, which is 5. So got the values of s and t. Now we're going to say when s is 3, what's the corresponding point on BC? When s is equal to 3, a point on BC, I can replace s by 3 in the parametric equation of BC. So I'll get x is equal to 8 minus 3, which is 5, and y is equal to 6 minus 2 into 3, 6. 6 minus 6 is 0. So the point on the first line, point is 5, 0. That's the point on the first line. When t is equal to 5, a point on AC will be, I put it back into AC, t is 5 I know, so I replace it, 0, 0 plus 5 is 5, y coordinate is 5 minus 5, which is 0, so a point on AC would be 5, 0. So I can see that there is a common point between AC and BC, so they intersect and the point of intersection has to be C. So the two lines intersect at 5, 0 and C is 5, 0. There was a B part to the question to show that it is isosceles triangle, which two sides are equal in length. So now that you have the 3 points A, B and C, use distance formula to find the distance between A and B. Distance formula, root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So use that formula to find the distance between A and B, distance between B and C, distance between A and C, and figure out which two are equal. Okay.